We're practically drowning in a material that we actually designed to last forever. But what if the solution to our plastic nightmare has been here the whole time, just quietly doing its thing in the darkest corners of our planet? Let's dive in and see if nature's oldest recyclers could really be our secret weapon.
I want you to just let that sink in for a second. More plastic than fish. This isn't just some scary headline, it's a very real projection that shows you just how big this crisis is. A quote like this is exactly why scientists are now looking for some pretty radical solutions, and sometimes in the most unexpected places.
So here's our game plan. First, we're going to get a handle on just how massive our plastic problem is. Then we'll meet our unlikely hero, fungi. We'll look at a really groundbreaking discovery, get into the science of how they actually eat plastic, and finally look at what the future could hold for this amazing natural solution.
Okay, so let's start by putting some numbers to this crisis. Just how deep are we in this plastic mess?
400 billion kilograms. That's how much plastic we humans crank out every single year. It's a number so huge it's almost meaningless, right? And a massive chunk of that ends up, one way or another, in our oceans.
And here's the real kicker, the central paradox of plastic. The very thing that makes it so useful to us, its incredible strength and durability, is the exact same thing that makes it an environmental nightmare. See, it doesn't really decompose. It just shatters into smaller and smaller bits, creating this invisible smog of microplastic pollution everywhere.
All right, enough of the doom and gloom. Let's shift gears and talk about a potential solution. It's time to meet the humble fungus, which is basically Earth's master demolition crew.
This right here is their secret sauce. Fungi have evolved over millions of years to break down the toughest stuff in nature, like lignin, the super tough material that makes wood, well, woody. And that unique ability is what makes them such an exciting possibility for tackling our tough, man-made materials.
Just look at this. This gives you a tiny glimpse into how unbelievably diverse the fungal kingdom is. And get this, scientists think we've only identified less than 10% of all fungal species. And in the ocean, it's probably less than 1%. It's like there's this huge, undiscovered library of biological superpowers just waiting for us.
So how do they actually do it? Well, they have this amazing demolition toolkit. First, they have something called hyphal growth. Think of it like tiny roots that can burrow into really tough surfaces. Second, and this is the big one, they shoot out these things called exoenzymes. They're like microscopic molecular scissors that chop up complex stuff outside their bodies. And third, they are incredibly adaptive. They can literally evolve to eat new things in their environment.
Okay, so now for the main event. This is where we see those fungal superpowers get put to the ultimate test.
I mean, that's the million-dollar question, isn't it? Can an organism that evolved to eat trees and leaves really make a meal out of a synthetic polymer that was cooked up in a lab? Well, the answer, incredibly, is yes. Researchers at the University of Hawaii found fungi right in their local coastal waters and were floored to find that more than 60% of them could break down polyurethane, the plastic in foams and adhesives. This wasn't some super rare needle-in-a-haystack discovery. The ability seems to be surprisingly common.
And it gets even crazier. They figured out they could actually train the fungi. By just leaving them with plastic as a food source, some species got better at eating it, increasing their speed by about 15% in just 3 months. That's that adaptive superpower in real time.
And this isn't a one-off. Thousands of miles away, in the middle of the North Pacific garbage patch, other scientists identified a completely different fungus, this Perendiodontium album, that was chowing down on polyethylene. That's the most common plastic in the world. We're talking shopping bags, food containers, you name it. So, we know they can do it. The big question now is how. Let's pop the hood and look at the actual science behind this amazing feat.
It all comes back to those exoenzymes, those molecular scissors we talked about. A fungus can't just, take a bite out of a plastic bottle. It has to spray out these special proteins that go and snip the long, tangled-up plastic chains into smaller, bite-sized pieces that it can then absorb as energy.
So the whole thing happens in about 3 steps. First, the fungus has to colonize the plastic, kind of getting a foothold on the surface. Then comes the cool part, depolymerization. That's when the enzymes go to work, breaking down the plastic. And finally, you have mineralization, where the fungus actually absorbs and metabolizes those little plastic bits, releasing harmless stuff like CO2 and water.
What's so cool is that it's not a one-size-fits-all kind of deal. Different fungi have different enzyme tools for different jobs. You can see here,
Enzymes like lacases are specialists for really tough plastics like polyethylene, but then you have others like cutinases that are experts at breaking down PET, which is what your water bottles are made of. It's like having a hyper-specialized toolkit with a unique key for every type of plastic lock.
Now, this is all incredibly exciting stuff, but we have to be real for a second. How do we take this amazing talent from a little petri dish in a lab and scale it up to fix, say, the entire Pacific Ocean?
And this is where we need to balance the hype with reality. Look, the challenges are real. In nature, this process is super slow. Plus, some of these fungi need a little help, like the plastic has to be broken down by sunlight first. But on the other side, the opportunities are just, wow. Imagine we find a new deep-sea fungus that's even better at this. Then we use genetic engineering to supercharge it. And then we could even create these custom enzyme cocktails designed to attack specific plastics. We're talking about a whole new field of science opening up.
Which really brings us back to the big question. We are just scratching the surface of this hidden world of fungi and their insane biochemical powers. No, this probably isn't going to be a single magic bullet, but the discovery of these plastic-eating microbes has opened up a brand new, totally natural front in our war on pollution. Maybe, just maybe, the answer has been right under our feet and floating in our oceans the entire time.